eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The first images from NASA's James Webb Telescope are absolutely breathtaking. They don't even seem real. But some of us are a little confused about what we're actually looking at.
In the depths of space, the James Webb Space Telescope has glimpsed something utterly shocking. Bright lights eerily reminiscent of Earth's bustling cities beaming from Proxima Centauri b, an exoplanet 7 trillion miles away. Are you ready to confront what lies beyond the stars? Dare we imagine the possibilities of finding a civilization not our own? What secrets could they hold, and what does this mean for humanity's future? Interstellar signals hint at alien life. As the world grapples with the implications of this startling find, the James Webb Telescope's latest observations suggest more than mere random light. Could these be deliberate signals from an advanced civilization on Proxima Centauri b? Each flicker and flash across this immense distance invites speculation that we might be on the brink of the most monumental discovery in human history: contact with another world. This segment of space, once thought silent and desolate, now whispers of possible life, and with each piece of data, we inch closer to possibly rewriting history. Stay with us as we delve deeper into the James Webb's findings, each revelation bringing us potentially one step closer to answering the age-old question: are we alone in the universe? As the telescope explored the vastness of space, it found something fascinating on Proxima Centauri b, a distant exoplanet. It detected lights that looked like the ones from cities on Earth, hinting at the possible existence of an alien civilization on this far-off planet. This idea has generated a lot of excitement and curiosity among scientists. It could be the discovery they've been waiting for, pointing to the presence of intelligent life forms who might be organizing their communities in ways we've never imagined. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as especially complex. This complexity is because, unlike most rocky planets that absorb sunlight and emit infrared energy, this exoplanet behaves differently due to its unique relationship with its star, Proxima Centauri. But this isn't the only remarkable part. The discovery by the James Webb Space Telescope highlights just how powerful this tool is. The telescope's ability to detect infrared light was key in finding these unusual lights, showing us how much more there is to learn. The heat signals from Proxima b are crucial for understanding what its atmosphere might be like. Scientists want to keep using this telescope to learn more about the planet's atmosphere and to explore if it could possibly support life. The James Webb Telescope is excellent at detecting infrared light, which helps it observe Proxima Centauri b's nighttime activities. Many space telescopes struggle to notice faint lights in the vast darkness of space, but the James Webb Telescope can capture even the tiniest glimmers. This makes it ideal for checking if the rumored city lights on Proxima b's dark side are real. The telescope can detect any artificial lights in space if they emit within a specific narrow frequency that's much finer than regular starlight. Proxima b has a close relationship with its star. On the side facing the star, many solar panels would gather energy from the intense sunlight, and its boundary with the dark side would also reflect some light. As Proxima b orbits its star, it experiences day and night cycles similar to Earth, with hot days and cooler nights. The planet shows big differences in temperature, mostly because of what it's made of. For instance, if Proxima b doesn't have an atmosphere, the temperature difference between day and night would be extreme. Without atmospheric gases or oceans to even out these extremes, the day side would become extremely hot, while the night side would freeze. These sharp temperature differences interest astronomers because they can reveal details about Proxima b's atmosphere. With its strong infrared imaging abilities, the James Webb Space Telescope can measure the planet's heat, giving important clues about its atmosphere. But this isn't the most interesting part. The James Webb Telescope's orbit around Earth is aligned with Proxima b's orbit, allowing it to observe the planet's day and night cycles every 11.2 Earth days. If Proxima b does have an atmosphere, the next step would be to study its chemistry to see if it might support life. Signs like oxygen, water vapor, and methane could mean the planet has conditions suitable for life. Finding these components on Proxima b would make the case stronger for it being able to support life, leading to detailed measurements and studies of the light passing through its atmosphere. But here's the catch. The James Webb Space Telescope can only look at a few of the nearest planets that might be habitable. For a broader look at many more planets, scientists are eagerly waiting for the Extremely Large Telescope, ELT, which will start working in 2028. The ELT is expected to give a clearer picture of what faraway planets' atmospheres are like and how likely they are to support life. The scientific community is looking forward to the new insights that the ELT and other future telescopes will bring. In the meantime, the James Webb Space Telescope remains an important tool for studying planets outside our solar system. Even with its limitations, it keeps providing valuable information that could change our understanding of the universe now and in the future. As we dive into the next chapter, we'll further decode these exciting findings, inching closer to potentially groundbreaking revelations. The advancements in space telescope technology. Looking ahead, new space telescopes will aim to reduce the bright light from stars, making it easier to see the planets that orbit them. This is like shading your eyes with your hand to see better in bright sunlight. By dimming the starlight, these advanced telescopes will be able to capture the faint glow from distant planets more effectively. This clearer view will help scientists study the atmospheres of these planets and determine if they might support life, but of course this is no easy task. Scientists have to be careful to tell the difference between gases that are produced by living organisms and those that come from natural processes like volcanic eruptions. Their goal is to fully understand these distant planets so they can accurately identify signs of life and avoid being misled by natural events. The James Webb Space Telescope opens up new possibilities for future discoveries. As we continue to explore space, we get closer to understanding more about the vast universe and our place in it. For as long as humans have existed, we've wondered if we're alone in the universe. This question still drives many scientists today. Currently, the JWST is examining different planets and moons, searching for signs that life might exist beyond Earth. The idea that life might exist elsewhere in the universe is becoming more popular. This growing belief has people excited about the possibility of finding alien life. In 1984, two American astronomers, Jill Tarter and Thomas Pearson, began a project called the Search for Extraterrestrial Intelligence. They created a non-profit organization to listen for radio signals from space, hoping to catch something sent by intelligent beings. They use radio waves because these signals can travel long distances without losing strength. The Allen Telescope Array in California, comprised of 42 radio telescopes, is at the heart of their work. Even though SETI has been listening for over 30 years, they haven't yet found any clear signs of alien life. But Jill Tarter is still hopeful. With today's advanced technology, she believes that a big discovery could be just around the corner. She dreams of a worldwide effort to discover if we're alone in the universe. Recently, excitement grew when NASA announced that the James Webb Space Telescope might have spotted something that looks like artificial light from a city on a nearby planet. The JWST, positioned 1 million miles from Earth, is crucial for space exploration. It sends back detailed information about the oldest parts of the universe and is specially designed to capture details we've never seen before. This helps us learn more about how galaxies, stars, and planets form. Astronomers are using the JWST's advanced tools, like its precise camera and special filters, to study the light from stars and planets. By focusing on specific types of light, the telescope helps scientists figure out the physical and chemical makeup of distant worlds. But this isn't the most amazing part. The JWST goes beyond just observing. It actively studies the atmospheres of other planets, searching for even the tiniest signs of life. With its unmatched ability to explore the cosmos, the Webb telescope is leading us into a new era of discovery. Researchers have recently made some eye-opening discoveries in the universe. They've found much more material hidden in massive galaxies than they ever expected. These findings are pushing scientists to rethink their ideas about how the universe started and evolved. Each new discovery from the James Webb Space Telescope, JWST, brings us closer to understanding the far reaches of space and what life might exist beyond our planet. New discoveries in the search for extraterrestrial life. With the help of the JWST, scientists are exploring deeper into space than ever before. They're gathering information on distant worlds that could help answer big questions about these far-off planets. Just 20 years ago, our knowledge of planets outside our solar system was minimal, but since then, astronomers have found over 4,000 exoplanets orbiting other stars. This shows how powerful our curiosity and technology have become. NASA believes that these findings are just the beginning, suggesting that there could be trillions more exoplanets waiting to be discovered. As researchers continue their space explorations, they are keen to find places where alien life could exist. Sometimes they come across clues that suggest they are on the right track. For instance, the Galileo spacecraft made an accidental discovery near Jupiter that hinted at possible plant life. This was a groundbreaking moment, marking the first detection of what's called a biosignature, specifically the vegetation red edge, VRE. This method detects life by studying how light reflects off it. Now, the JWST is equipped to explore further into the search for extraterrestrial life, focusing on planets that orbit within the habitable zones around their stars. But that's not all. If these signs of life are confirmed, the VRE could revolutionize our approach to finding intelligent life beyond Earth. This might open up a thrilling new chapter in space exploration, taking us into unknown regions of the universe. Imagine this. Sunlight passes through different layers of a planet's atmosphere, breaking into various wavelengths that are absorbed by atoms and molecules. This process creates a unique spectral signature like a fingerprint, which we can study using a technique called spectroscopy. Scientists are confident that planets bathed in starlight offer a unique chance for the Webb telescope to observe this light as it passes through their atmospheres. These observations are key to understanding what these atmospheres are made of. The James Webb Space Telescope could be the crucial tool needed to figure out the composition of atmospheres on distant planets. On planets similar in size to Earth, atmospheres are usually made up of carbon dioxide, nitrogen, and oxygen. These gases could potentially support life. However, if strange or unexpected compounds are found, it might suggest the presence of different life forms or even advanced civilizations elsewhere in the universe. For example, chemicals like chlorofluorocarbons, which are human-made and used in refrigerators and manufacturing, could indicate intelligent life if found on another planet. As we close this segment of our astronomical adventure, we remain poised on the brink of new discoveries in the next space exploration chapter. A path through the extremes of space. Such a discovery would significantly expand the possibilities for astronomers, opening up new areas to explore regarding the atmospheres of other planets and the potential for civilizations beyond our galaxy. Thinking about life beyond Earth opens up a wide range of possibilities that go far beyond what we know about life here. We often assume that life needs a mild climate to survive, but the truth could be much more complex. Take extremophiles, for example. These are bacteria that thrive in conditions most life forms would find unbearable. They can survive in extreme heat with temperatures up to 250 degrees Fahrenheit and in highly acidic environments with pH levels below 3. Their existence shows just how adaptable life can be, even in the most extreme conditions. As our search for habitable planets continues, finding life in unexpected places forces us to rethink our understanding of the universe. But this is only the beginning. Space is vast and varied, so our search for extraterrestrial life must be broad and thorough, starting with Earth-like planets that orbit stars similar to our Sun. Doing research is really important, but it's just as crucial to stay open to new and unusual ideas. This includes looking into planets that orbit red dwarf stars, which are common in the universe. These stars might not be as bright or warm as our Sun, but they offer unique places to explore the possibilities of life in different environments. Red dwarf stars have a much longer lifespan, which gives plenty of time for life to evolve in complex ways. Take the TRAPPIST-1 system, for example. It orbits around a dim red dwarf star and has 7 rocky planets that are similar to Earth. Out of these, 3 are thought to be in the habitable zone, meaning they could have liquid water on their surfaces. Although the TRAPPIST-1 star is smaller and cooler than our Sun, its gentle light might still support life. Scientists study the light from this star to learn more about the possible living conditions on these planets. Recently, research by the James Webb Space Telescope has shown that this star system is 41 light-years away in the Leo constellation, making it a prime target for further study. But this wasn't the most surprising part. Ward Howard, a NASA Sagan Fellow and the lead researcher from the University of Colorado Boulder, shared his excitement about these discoveries. He pointed out that the JWST has given us incredible new details about planets around other stars that have atmospheres similar to Earth's. He stressed how important it is to understand these stars to really get a sense of the planets that orbit them. Among all the stars in the universe, Proxima Centauri stands out because it's so close, only about 4.25 light-years from our Sun. This star is very faint, making it hard to see from Earth without a telescope. The low brightness of Proxima Centauri means that any planets with life would need to be much closer to the star than Earth is to our Sun to stay warm enough. On August 24, 2016, astronomers confirmed that they had found an Earth-like planet called Proxima Centauri b. This planet is located in the habitable zone of Proxima Centauri, the closest star to our Sun. Proxima Centauri b is about 1.3 times the mass of Earth and orbits much closer to its star than Mercury does to our Sun. This close orbit makes it a good candidate for having liquid water and possibly life, since it's in a zone where temperatures might be just right. Finding Proxima Centauri b wasn't easy. Astronomers used highly sensitive tools to detect tiny movements in Proxima Centauri caused by the planet's gravity. Even though the star is nearby, its faint light, due to its small size, made this discovery quite difficult until this breakthrough. The planet orbits in what scientists call the Goldilocks zone of Proxima Centauri, where it's not too hot and not too cold for liquid water to exist. However, there's a challenge. Proxima Centauri is a red dwarf star known for emitting strong flares. These flares could potentially harm the planet's atmosphere and affect its ability to support life by exposing it to more radiation than Earth receives. The discovery of Proxima Centauri b adds an important piece to our understanding of the universe and raises hopes of finding more planets that might support life. With upcoming telescopes like the James Webb Space Telescope and TESS, scientists are eager to learn more about the atmospheres and environments of exoplanets like Proxima Centauri b. But this discovery also brings more questions. What is Proxima b really like? Could it support life? Future missions will focus on finding answers to these strange possibilities. At just the right moment, enough light shines over, strong enough to melt frost and maybe even help life to start. Proxima b, a fascinating planet that orbits the small red star called Proxima Centauri, is only 4.6 million miles away from its star. This close relationship with its star puts it at risk, which could make it hard for life to survive there. One major threat comes from powerful solar winds from Proxima Centauri, which could strip away the planet's atmosphere completely. But despite these challenges, Proxima b gets just enough light to keep its surface warm enough to support liquid water, something we know is crucial for life. Proxima b's close orbit around its star causes something called tidal locking. This means one side of the planet is always in daylight while the other side is stuck in constant darkness. This creates a world of extremes, one half always lit, the other half always dark, much like how the same side of the moon always faces Earth. Even though Proxima Centauri is a small star, it still gives off enough light and warmth that might make life possible on Proxima b, similar to how life exists on Earth. What if the lights